Okay. Go ahead.
Oh, it's mine? Okay. Well, I guess I was hoping that this is more like a Q&A than an actual lecture. So you guys are going to ask me questions. What did you do? What did I do? How about I start with what am I doing? Right.
Don't move it because you're going to make it really loud and crackly.
So I am doing my PhD in electrical and computer engineering. I do research in circuits, in particular microchip technology, for DNA detection. And it's very hard for me to describe it, but because you can't really see something that's out there yet. It's supposed to be the next thing. So the closest thing that you can think of is a camera. And the way it works is, let's say you have some DNA material, and you want to know whether it is cancer or it is not harmful, right? What do? Well, it turns out that you can actually do something to it to manipulate its optical properties, and it will give off light to different magnitudes based on its properties. So if you detect more light, maybe that means it's cancerous. If you detect less light, maybe it's okay. It's same for bacteria. I mean, if you have, say, a contaminated sample and you extract the DNA out of it, and you sense the light giving off from the DNA, you would be able to tell what kind of bacteria it is. So basically, my job is to build a camera that can sense this light. Well, can you use a regular camera? You may, but the performance will be very bad. So we're talking about light levels that are 10 times, 100 times, even 1,000 times less than what we see every day. So that is the challenge. So I'm going to talk about how I came to that, and then I'll open the floor up to questions. I think that's better because I've been kind of torn apart. There are a lot of things that I want to say to you guys, but there's too little time. So let me start with how I came to do this. When I was a kid, there were no Facebook, there were no Twitter. I was fortunate enough that my dad was in the telecom company in Hong Kong. It was the only telephone company in Hong Kong, and he was involved in computers and maintenance. So I had my first computer when I was 6 years old. It was a 386 running at 20 megahertz. 20 megahertz. 2 megabytes of RAM. 2 megabytes, not 2 gigabytes, 2 megabytes of RAM.
Wow.
And a 40 gig hard drive. And it turned out that hard drive was actually 2 drives. Because 20 megabyte, not gigabyte, 20 megabyte was the fastest and biggest hard drive you could find. So I did play some games on it, but the computer wasn't really the toy that you can be around with for the whole day. So I played with Lego, I played with Coca-Cola cans, paper, scissors, tape, glue, and make all sorts of stuff. Stack 3 cans in a row and then put a cone on top and some fins, and you have a rocket. So I would bring this. One day it turned out it's in a family gathering. I brought this rocket to my cousin, and he liked it very much. And then the next moment, my aunt was basically complaining to my cousin, "Why couldn't you make a rocket like that?" At that point, it didn't sink in. It was okay. Like, why were you so mean to my cousin? I don't understand, right? But anyway, and then I realized that okay, maybe I just like making stuff. And then I started playing around with Legos, and there weren't these fancy pieces. It was just blocks. It was just rectangular blocks. And I built all sorts of things until Lego got better and it's got wheels and motors, and I still started building, things that can carry a load. I know it's pretty geeky, right? Basically I didn't know how to make it. I asked my dad, can you build me a prototype? So he built me a prototype, and it could carry, let's say, one Bible, right? And then I started, that's not fun, you can carry a Bible, so what? Let's have it carry two. So I built another prototype that could carry two Bibles, and then it could carry actually up to 5 Bibles with the same parts. So that was as far as I could get until it actually broke my Lego and I couldn't do it anymore. And then I built boats in the bathtub and all that stuff.
Lego boat.
Yeah.
A Lego
Oh,
boat
you
that
know what?
floats.
You know what? In McDonald's, when you order big breakfast, it came with that yellow cover, right?
Yeah.
It's actually a great structure for the hob.
Yeah.
So you flip it around, it's a boat, right? And then you put a motor and you can actually move in your bathtub,
True.
right?
Yeah.
Because I had no material. Like if you make a boat out of paper, it's gonna melt, right? Doesn't yeah, it's gonna disintegrate. It doesn't work. So yeah. So that was a great find. The McDonald's big breakfast cover. And anyway, so I did like to draw too. I draw the floor plans. There's a living room, there's a dining room, how big they are, sizes, dimension, them, all that stuff. And then my mom said, "Yeah, maybe you can be an architect someday." And I was like, "Okay, yeah, maybe." And then I went, and then I got to high school, and high school was fun. Computers got better, so I started playing games on it. And in the old days, computers were slow. You buy a computer for $3,000, it's still a piece of crap.
Swear.
Crap is not swearing.
Okay.
Anyway, so still a piece of crap. Okay. So so the thing is, how do you optimize its performance so that you can at least play some decent games on it? Well, you look at all the articles and say, okay, this is a good part for video, this is a good CPU speed for it, and then you read all the numbers and you put together. Back in the old days, it doesn't come in one piece, right? You have to put it together. At least somebody will put it together for you, and then you buy it, right? If you are the person who customize it, you would be able to tailor to your own needs. Nowadays, it has been, it has changed a lot. Now it's so fast that you can pick up a laptop for $500 and you can play all the games you want. It's not a problem. So that was when I started looking into computer hardware and starting my own business. It was a small business, just among friends, and building computers for them, and maybe charging them a premium for it, so that I can actually buy my own parts to build my own computer, because I wouldn't ask my dad for computer money.
How old were you?
Grade 10.
Oh, wow.
So I remember back then it was Pentium 2 just came out. It was a 233 megahertz Pentium 2 with 64 megs of RAM. That was around the performance we were able to achieve. So that was high school, and then a time came to kind of pick, okay, what would you like to do in university? So I said, okay, how about engineering? I had no idea what engineering really was all about back then. It was just because all my other cool friends or smart friends are going to engineering. That's why I did. And well, I mean, with some relationship to my interest in computers, but that was that. Actually, that year we had around 15 friends going into engineering from my high school. So that was quite a bit. I met all my buddies there. So then, okay, I thought, well, yeah, that's great. Maybe I can be a computer engineer. So after 4 years, I can come out and make some good stuff. And unfortunately, I realized that that is not the case. After 4 years of education, you're still pretty dumb. and to the point that you basically there is no innovation. You can't really start something new. You don't know enough to do something exciting. At least for me. So then, but also at the same time, I really didn't like programming that much. So I switched from computer engineering. I did my computer engineering. I finished my degree, and I started my master's degree in radio frequency circuits. What does that mean? That means basically the communication circuit in each of your cell phones that enables the device to talk to the stations and talk to other cell phones. So that's more like electrical engineering. So I changed from computer engineering to electrical engineering, and I will define those terms later on. And so that was fun, but there was a problem. After 2 years of research, I realized that the radio area is pretty mature. That you can't really do a lot of innovation in it because the radio was invented, 50 years ago, and there is not much new stuff you can do. After all, the radio architecture is very well established. The new radios coming out are basically achieving higher speeds because of some advancements in technology, but really the circuits are dead. And so I started looking into how about biosensors, biocircuits, because the biosensor area is just in its infancy. Nobody has done it before. There are a lot of very big, bulky equipments, very expensive in the hospital, and they're fragile. They need a lot of maintenance. They are humongous. You can't fit a lot of them in a single room. They are very expensive. The technology is there, but in order for it to achieve its performance, you need a lot of brute force engineering to do it very well. So they are bulky, they're expensive, they are just not great. So there is a new trend in miniaturization and in optimizing its design to bring these equipments down to a very small scale, maybe the scale of like a printer, maybe even smaller, in the scale of like a USB stick, where you can do a lot of rapid tests in a very small amount of time and do it very cheaply, so you can throw it away and you use a new one. So this is how I came to my research topic today. And this is as much as I'm going to say in one shot today. So I'm going to open the floor to questions. Now, before I do that, I know people will be a bit shy for the first 10 minutes. So I'm gonna raise a couple of key questions that I find it very important to address. And the first one is engineering versus science. What is the difference? Anyone want to take a stab at it? Engineering versus science. Anything.